Okay, so Junior Roberts here again, and we're doing another physics worked example. So let's go right into this video. So this question here says, a student investigating a relationship between extension and force for a spring of original length 6 centimeters obtained the results seen in table 1 below, right? And this here is our table 1, right? So we have our data, right? So now let's scroll down and see what the question wants us to do. So the question wants us to do a couple of things. The first thing they want us to do is to complete table 1 by calculating the force F and the extension E of the spring. And we're told that the acceleration due to gravity is 10 newtons per kilogram, right? So let's look back up at our table. So we're given the mass, we're not given the force, we're asked to calculate the force, we're given the final length of the spring, and we're also given the original length of the spring, right? And we're asked to find the extension. So I'm going to first start with the force. Now, whenever an object is in a gravitational field, it will experience a force, right? And that force is what we refer to as the weight, of the object, right? And there's incidentally a formula that we use to find the weight of an object. So I will write that the weight is equal to mass multiplied by the acceleration of the force due to gravity, right? Which in this case we're told is 10 newtons per kilogram. So in simpler form I can write that weight W is equal to mass times gravity, right? Now whenever we are trying to find the weight of an object, we need to express our mass of the object must be expressed in units of kilograms. So if we look back at our table, we see that the value that the mass is given in is in grams as listed right here. So we now need to actually convert from mass, we now need to convert from grams to kilograms and then use our formula to find weight, right? Now whenever we're converting from grams to kilogram, we have to divide by 1000, right? So what we would have to do first is to divide the mass by 1000 to get it from grams to kilograms, and then multiply by the acceleration due to gravity, which is 10 newtons per kilogram. So I'm gonna do that right now to fill out the table. So let me get the calculator out. Alright, so for each mass which is in gram, we're first going to convert it to kilograms. So we're going to say 20 divided by 1000, right, equals 0.02, and then we're going to multiply that now by 10, which is the force due to gravity, right? And we get that the force here is, right, so the force here would be 0.2 newtons. Okay, so again we're going to move on to the other one, and then again what we will do is we're going to divide our mass, which is in grams, by 1000 to get it in kilograms, and then we're going to multiply by 10 newtons per kilogram, which is the force due to gravity, right? So essentially what we do, we have our mass, right? We divide our mass by 1000 and then we multiply by 10, right? So a short way to do it is, if we say that 10 cancels this 0, we can simply divide our mass by 100 and we'll get the same answer. So each of these, what I'll be doing going forward is to just simply divide by 100. So if we divide by 100, we will get 0.4 for this one right here. Then we're going to get 0.6, 0.8, 1.0 and 1.2, right? And that would be our force, right? Now in terms of the extension, to find the extension, we will simply subtract the final length from this original length, right? So if the final length here is 60.5 and our original length was 60 centimeter, it means then that our extension is 0.5 centimeters, and our extension here would be 1.0, here to be 1.5, because again what we're doing is that we're subtracting the original length from the final length in each case, and 61.5 minus 60 centimeters gives us 1.5. Then this one will be 2.0, here will be 2.4, and here would be 3.0. Right, and that's our table completely filled out. So let's move on and see what else the question wants us to do. Okay, so the question wants us to plot a graph of extension against force on the graph paper on paper 2. So this is our graph paper, which we'll be using to plot our graph of force against extension, right? So let's start by simply labeling our axes, right? So we'll have our x-axis right here, and we'll have our y-axis here, right? And since we'll be plotting, the question says we're supposed to plot extension against force, means then that we're going to have extension on the y-axis. So I can put that in right now. So I will have extension, right, E in units of centimeters, right? And then on the x-axis, I'm gonna have force, F, in units of Newton, right? So after I have my two axes labeled, right, I'm gonna go ahead and draw the axes, right? So I'm gonna pull on the straight edge to help with getting that done. Okay, so I have my two axes drawn up, right? So now I can actually choose a suitable scale that I'll be using to plot the points. So let me look back at the table to get an idea of what the values that I'll be plotting. Again, I'm plotting extension against force. So extension is on the y-axis and force is on the x-axis, right? So looking back at the table, I know I'll have extension on my y-axis, right? So I'll need to choose a suitable scale that will accommodate the values from 0.2 to 1.2. Similarly, on the y-axis, I need to choose a suitable scale that can accommodate all these values. All right, so for the x-axis, I'm going to be using a scale of, since I'll have force on the extension and force goes from 0.2 to 1.2, I'm going to use a scale of 2 centimeters to 0.2 newtons. Right, so I'm going to have 2 centimeters there, 2 centimeters, 2, 2, 2, 2, right? And then we're gonna have 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, and I can also include 1.4. Okay, so for the y-axis, I'll be using a scale of 2 centimeters to 0.4. Right, so I'm going to say that's 0.4, right, 0.8, 1.2, 1.6, 2.0, 2.4, 2.8, 3.2, and I can also include 3.6. Right, so that's my axes completely labeled. Again, let me just write the scale that I use. So for the x-axis I use a scale of 2 centimeters equal 0.2 newtons, and for the y-axis I use a scale of 2 centimeters equal 0.4 centimeters. Alright, so now we can use the values in the table to plot the points, right? So when the force is 0.2 newton, our extension is 0.5 centimeters. So 0.2 to 0.5. Right, so 0.2 here maps to 0.5. Right, so I'm going to put my first point right here, and I'm going to be using dots in circle, right, to plot the points. Right, then 0.4 goes to 1.0. So 0.4 goes to 1.0, which is right here. Zero 0.6 goes to 1.5. So 0.6 to 1.5. So this is 1.2. So 1.4. So 1.5 is about right here. Then we have 0.8 goes to 2.0. So 0.8, 2.0, which should be right here. And then 1.0 goes to 2.4. So 1.0 goes to 2.4. Right, and then we have 1.2 going to 3.0. Right, so 1.2 goes to 3.0, which is right here. Right, so now that I have all my points plotted, I'm going to be drawing my best fit straight line. So I'll be using the ruler to assist with this. Right, so this to me looks like the best fit straight line. So I'm gonna go ahead and just draw my best fit straight line. Right, so using the ruler, right, and that is my best fit straight line. So let me also include a title, suitable title for this graph, right? So we can say graph showing a plot of extension against force for a spring, right? And that is our title. Right, so let's look back to the question. Right, so we have just plot the graph of extension against force. Now the question wants us to calculate the slope using the graph. Right, now we know for a graph the slope S is equal to the change in y, which is y2, minus y1 over the change in x, which is x2 minus x1. Right, so to do this, we will first have to draw a large triangle. Right, so let me just go ahead and draw that large triangle. Alright, so I have my large triangle drawn, so I can read off my values. So my y2, which I'll get from right here, would be, well, this is 3.6, and here we would have 4.0. So therefore y2 would be 3.8 centimeters, right? So y2 is equal to 3.8 3.8 centimeters. Right, and then y1, which we'll get from right here going across to our y-axis, would be y1 is equal to 0.6 centimeters. Right, and then to get x2 and x1, we'll get x2 right here. This is 1.4, so here would be 1.6. So it means then that our value for x2 would be 1.4, 1, 2, 3, 4, 1.42, 1.44, 1.42, 1.44, 1.46 would be 1.46. So that's x2, and the value for x1 would be, this is 0.2, so we have 0.3 here, so 0.32. So x1 would be equal to 0.32. Right, so we can use these two values to determine our gradient, right? So we're going to say y2, which is equal to 3.8 centimeters minus y1, which was 0.6 centimeters. Right, so we have 0.6 centimeters divided by x2, which is 1.46 centimeters, and x1, which is minus 0.32 newtons. Actually, this should be Newton. Right? So now, when we say 3.8 centimeters minus 0.6 centimeters, we get 3.2 centimeters, and 1.46 newtons minus 0.32 newtons leaves us with an answer of 1.14 newtons. Right, and if we take out our calculator and find the quotient of that, we will have 3.2 divided by 1.14, and that gives us an answer of 2.81 centimeters per Newton. Right, and that would be our gradient, 2.81 centimeters per Newton. Right, so again, we have our graph, we have our straight line, and we have completed our table, which we use to plot the graph below. So again, this was Junior Roberts coming to you with realjuniorroberts.com. If this video was helpful, please hit the like button, consider subscribing and share so others would be able to benefit. If you have any questions, go ahead and post them below in comments, and I'll do my best to clear up any misconceptions for you. Thank you for watching.